All matter is anything that takes up space and has volume. It's things we see or sometimes small molecules that we don't see. So matter has properties that can either be classified as physical or chemical properties. Solids have properties that are different from gases and liquids. Solids have a definite shape. They don't have to have a container in order to have a shape. They have a definite volume, that is, they take up a certain amount of space. The particles in a solid are very close together and they're in a fixed arrangement. If you look at the amethyst here and these crystals, those crystals are formed because of this specific closely packed arrangement of the atoms in amethyst, which is basically silicon dioxide. Also, a characteristic of solids is that it moves very slowly. So solids have a definite shape, a definite volume. The particles are very close together and they move very slowly. Liquids have an indefinite shape but a definite volume. That is, if you have 2 milliliters of water, you have 2 milliliters of water. That's its volume. But if you can put it in different shaped containers, and it will change shape depending on the shape of the container you put it in. The particles are close together, but they move around a little bit more than the solid. The particles still move rather slowly, but it does have this definite volume. Okay, so liquids have indefinite shape, definite volume. The particles are close together and they move slowly, but they move faster, more fluidly than a solid. Gases have an indefinite shape, indefinite volume. Okay, they will take up the volume and the shape of whatever container you put them in. The particles are very far apart and they move very fast. So if you put these particles of gases in something like a balloon, they're going to move, bounce back and forth, and take up all the volume that they possibly can because they want to be as far apart from each other as they can be. So the three states of matter are solids, liquids, and gases. So when we compare them, if you look at shape, solids definite shape, liquids take the shape of the container, so they have an indefinite shape. Gases also take the shape of the container, so they have an indefinite shape. Volume, solids have a definite volume, liquids have a definite volume, gases have an indefinite volume, that is, they take the volume of their container. Arrangement of particles, in solids they are fixed very close together, liquids random and close, gases random and far apart. Very strong interactions between particles in solids, strong in liquids, and basically no interactions between particles in gases. Slow moving in solids, moderately slow to fast in liquids, very fast in gases. And in a solid, if you think about water, solid water is ice, liquid water is water, and gas would be steam or water vapor. So let's do a learning check. Identify each description as particles of a solid, liquid, or a gas. So these are characteristics of those. So take a minute and see if you can figure these out. Alright, so let's see how you did. Definite volume, but takes the shape of the container, is a liquid. Particles are moving rapidly. Rapidly moving is gas. Particles fill the entire volume of a container would be gases. Particles have a fixed arrangement, so they would be a solid. Particles close together but still moving randomly would be a liquid. So we mentioned that you can have physical properties you can also have chemical properties. Physical properties are characteristics that we can see or measure, and we can do that without changing anything about the substance. That would be like, what shape is it, the physical state, whether it's a liquid, solid, or gas, boiling and freezing points, density, which we've already learned how to calculate, mass over volume, and even like the color or odor of something. That is a physical property. Copper has physical properties. It is a reddish-orange colored metal. It is shiny. It is a conductor of heat, so we use it a lot in electrical circuits. It is a solid at room temperature at 25 degrees C. It has a very high melting point, 1083 degrees C, and you have to get it all the way up to 2567 degrees C in order to get it to boil. Identify the state of matter for each of the following: vitamin tablets, eye drops, vegetable oil, candle, or air in a tire. What is the state of matter? Solid, liquid, or gas? Okay, you probably did pretty well on this because these are things that you're very familiar with. Physical changes. Physical changes have to do with physical properties. It occurs in a substance if you change the state. That is, like if you've got liquid water and you boil it and you convert it to steam, you have changed it from a liquid to a gas, so that's a change of state. You can change the physical shape, where you've taken the gold foil and hammered it out into, well, they've actually done the opposite of that. They've taken a gold ingot and they've hammered it and made it super thin, so they made something called gold leaf, so they can wrap that around things. You can change, when you do this, you do not change the identity. That is, it's still gold, all right? Even though you have made it in a different shape or whatever, it's still gold. With my water example, if you boil the water, it's still water, it's just water gas in the gaseous state if you boil it. Physical changes, you know, things, you tearing paper into small pieces, as we saw the gold leaf from the gold ingot, pouring water into a glass. This is a change of shape because you've poured it from a bottle into a glass, and so it's changed its shape. It still could be the same volume, it's just different shapes. So take this learning check and see if you can figure out which of the following is a change of state, which is a change of shape. How'd you do? Okay, obviously chopping a log, you're not changing its state, but boiling water in a pot is changing state. Melting ice cream goes from a solid to a liquid. That's a change in state. Taking liquid water to ice in a freezer would be a change in state. Or cutting dough into strips obviously is a change in shape. So those were physical properties. Chemical properties describe the ability of a substance to interact or react with other substances, and by doing that they change into new or different substances. When you have a chemical change, the original thing you start with is turned into something different. It can be one thing that's different, or it could be more than one substance, and those substances will have new properties, physical and chemical. So you've changed it when you've made a chemical change as far as its composition. It will have a new composition. It will have new chemical properties and new physical properties. When you make caramel, you basically take sugar and you heat it up and you turn it into another form. Another thing to do is if you take an egg and you fry an egg, you have chemically changed that egg. You're not going to be able to take that egg back to its original form because you have changed it into something new. Examples of chemical changes: silver tarnish, where it's used to be nice and shiny and then it gets all black. Wood burning is a chemical change because you go from a nice piece of wood to like some ash blackened thing. Okay, that's a chemical change. Rusting iron, when you have an iron nail that's out in the elements or whatever, oxygen forms rust. It's a chemical reaction with the iron itself. It's actually iron oxide. So here is your learning check to classify these properties as physical or chemical. Remember, the composition has to change if it's chemical. If it's physical, it's typically a change in shape or state. Okay, so ice melting is physical. Copper as a shiny metal is a physical property. Burning something, though, like paper, is a chemical change. Tarnishing is a chemical reaction on the surface of a knife. And magnets removing iron particles is a physical change. It's not a reaction because when you get done, you still have iron particles. They're just somewhere else. Classify these finally as changes in physical or chemical. Burning a candle, ice melting, toasting a marshmallow, cutting a pizza, or iron rusting. Very good. You probably got the hang of this by now. Changes in shape or state are physical, sorry. And changing the composition of something is a chemical change. And remember, burning is always going to be chemical. That's it for 2.2. I'll see you back here when you get ready for section 2.3.